Okay, day 4. The first 3 days we worked with related rates, word problems using derivatives to find what we want. Today we're going to look at word problems and applications that would maybe we use the antiderivative or the integrals. So going back to what we did, we remember when we take the antiderivative of something, we get some sort of function with a plus c at the end. So we talked about how we would move this dx over here. I'll do it for both of them while I'm here. And then we took the antiderivative, and I get y was equal to, well, when I take the antiderivative, I go up by a degree, so it becomes x to the fourth. And I use the reciprocal of that, which is 1/4 times 2, so I get 1/2 plus 2x plus your c at the end. And on this one, I should write this as x to the 1/2. So I take its antiderivative, and I get y equals, let's see, it's x to the 3/2, and the reciprocal of that is 2/3. 2/3 times 8 is 16/3 minus 2x plus c. And those are my two general differential equations or antiderivatives. I'm going to take these antiderivatives by moving the dx over, and I know I have y equals x to the third. I need a 2 plus x squared. I need a 2 plus c, and now I could use my initial value of 110. I could do 10 equals 2 times 1 cubed plus 2 times 1 squared plus c. 10 equals 2 plus 2 plus c. I get c equals 6, and then I can rewrite this as y equals 2x cubed plus 2x squared plus 6 as my solution to the initial value problem. We're going to do the same thing over here, but let's pay attention. Notice my variable is t. So I get s equals negative 16t squared plus 100t plus c. I could plug in what I have initially, so I get 250 equals 0 plus 0 plus c, so c is just 250. It's nice when I have x or t equals 0, so I get s is equal to negative 16t squared plus 100t plus 250. So those are those two problems. I have another one here, except it's going to be a little bit more difficult because I'm going to move the dt over here. I'm going to take the integral. I get v equals 3t squared minus 4t plus c, except now my initial value is 2 comma 25. So 25 is equal to 3 times 2 squared minus 4 times 2 plus c. 25 is equal to 12 minus 8 plus c. 25 equals 4 plus c. c equals 21. So I get my v equation is going to be 3t squared minus 4t plus 21. And that's a review of what we did in our earlier units when we took antiderivatives. So we're going to apply what we've learned to a physics class. And if you don't realize this, but in physics class, displacement, we use letter S. That's usually measured in feet or meters or a linear unit. And whenever we take its derivative, I get velocity because that's usually measured in feet per second, meters per minute, or whatever. And then I take its derivative again, and I get acceleration. That's usually feet per second squared, meters per second squared, whatever you want to call it. So when I look at this, I'm going to use pink. I have s, its derivative, s prime is equal to my velocity, and I take another derivative, or s double prime is equal to v prime is equal to acceleration. So let's think about what we could do thinking in reverse. I'll use green. If if I have acceleration, if I go in reverse, I'm taking the antiderivative. Well, guess what? My velocity is going to be the integral or the antiderivative of a. If I do it again, take another antiderivative, my displacement is equal to the antiderivative of velocity. Okay? So displacement velocity is velocities, whose velocity is acceleration, and working in reverse, we have acceleration's antiderivative is velocity, and the antiderivative of velocity is displacement. So my application to physics, here's a little summary. When I take derivatives of displacement, I get velocity, and I take that derivative again, I get acceleration, and I take antiderivatives, and I get the other way around. And for vertical motion, for things moving up and down, when we throw things up in the air and they come down, we're going to use negative 10 meters per second squared or negative 32 feet per second squared for my gravity, depending if I'm using standard engineering, American engineering units, or the metric system. So I have the example of a tennis ball being thrown upward from a roof, and I have the roof at 55 meters and the ground at the velocity at 50 meters per second. So I have my initial height is equal to 55, and my initial velocity is equal to 50. And because I'm using height, I'm going to use h instead of s displacement. Well, the one thing I do know is that my acceleration on this tennis ball is just gravity. And I'm doing metrics, so that is equal to negative 10. If I want to do velocity, velocity is just the antiderivative of acceleration, or the antiderivative of negative 10 dt. My variable will be t for time. Well, I do all that. I get v is equal to negative 10t plus c. Now I could plug in that 0, 50. 50 equals negative, or 0 plus c, or c equals 50. And I get my velocity equation is negative 10t plus 50. That's my velocity equation. Then I could take this guy and figure out, well, height, or my displacement, is just the antiderivative of velocity, which is just negative 10t plus 50 dt, or h is equal to negative 5t squared plus 50t plus c, and I could plug in my initial value of 0.55, and I get 55 is equal to 0 plus c, so c equals 55. Or better yet, my height equation is equal to negative 5t squared plus 50t plus 55. These are the equations of the acceleration on that tennis ball, the velocity, and the height. So I want to know, when does it reach its highest point? Well, when something reaches its highest point, I have a velocity is equal to 0. If you think about this, the velocity going up is positive, the velocity going down is negative, and right here at the max is velocity is equal to 0. So I'm going to take my velocity equation, set it equal to 0, and I get 10t equals 50, or t is equal to 5 seconds. And that's when it hits its max. And then I could go and plug in h of 5 is equal to negative 5 squared plus 5 times 50 plus 55. And if I did everything correctly, I think I did, I get h at 5 seconds is 125 plus 55. I get 180, meters. Which, on a side note, you could not do this. There's no human that could ever do that. Stand on a roof and throw it 180 meters. Not feet, meters. So now the question is, how long it is in the air, or how long does it take to hit the ground? Well, when it hits the ground, h is equal to 0, so I'm going to take my height equation. 0 equals negative 5t squared plus 50t plus 55. I'm going to solve for t. I don't like all these numbers. I'm going to divide by negative 5. I get 0 is equal to t squared minus 10t minus 11. Makes my numbers a whole lot smaller. And now I can factor t minus 11, t plus 1. I get t equals 11 seconds is how long it's up in the air. And I also get t equals negative 1, but you can't go back in time. So at 11 seconds it's up in the air, and it wants to know the velocity when it hits the ground. So I'm going to use my velocity equation, which is here. At 11 seconds, I plug in 11, negative 10 times 11, plus 50. My v of 11 seconds is negative 60 meters per second. It's pretty darn fast. It's 134 miles per hour. I don't think anybody's going to hit the ball, throw a ball going 134 miles per hour. So I want to figure out the acceleration of a car that goes 0 to 60 meters per second in 10 seconds. Well, it says constant, which means something is linear. And if something is linear, it has a slope, and slope is just change in y over change in x. Or for this example, a is change in v over change in t, which is 0 minus 60 over 10, which is 60 over 10. So my acceleration is 6 meters per second squared. Okay, next I'm going to do the same idea, except I'm going to draw a graph of what's going on. I have velocity in feet per second. That's 50. It's 5. This is time in seconds. And it is braking from 50 feet per second to 0 in 5 seconds. So it says constant. So this is linear. That means my acceleration is change in velocity over change in time. So I'm going to try to draw this straight best I can. So there's my graph of this. If I want to determine the acceleration, my acceleration is going to be 0 minus 50 from 5 to 0 seconds, which is negative 5 over 5. So my acceleration is negative 10 feet per second squared, and that is the slope of this line. So what I'm going to do with this, we're going to be able to figure it out a lot. Now I could do it a couple ways. One way that I can do is figure out what is the area under this graph. So I'm trying to figure out this area. And that will represent the total distance traveled. If you remember what you did freshman physics class, this is what you did. So if I want to find this area, well, this is just a triangle. And area is 1/2 times base times height, or specifically 1/2 times the base is 5 seconds. The height is 50 feet per second. And I can see that my seconds will cancel, and 50 times 5 is 250, half of that. So my area is 125 feet, and this is my distance traveled according to this model. But that's using geometry. What I really want to do is use anti-differentiation or calculus. So if I'm going to use anti-differentiation, I know when my time is 0, my velocity is equal to 50 feet per second, and my distance that I traveled is 0 feet. Well, I already did the acceleration. We said the acceleration was -10 feet per second squared. So when I want to do my velocity, I take the integral, or the antiderivative of my a, which is -10 dt, and I have my velocity is -10 t plus c, and I could plug in 0, 50. 50 equals 0 plus c, or c equals 50. So my velocity equation is -10t plus 50. But now I want to find my distance equation. So distance is the antiderivative of my velocity, or -10t plus 50 dt. And if I do this correctly, I get d is equal to -5t squared plus 50t plus c. Now I could plug in 0, 0. I get 0 equals 0 plus 0 plus c, or c equals 0. Or my distance equation, I'll do the purple, is equal to -5t squared plus 50t. This is my distance equation. This is my velocity equation for this car that's braking, and this is my acceleration. But I want to know what's the distance traveled. Well, this up here, I have to use t is equal to 5 seconds, because that's how long it took to stop. So when I plug in 5, I get d of 5 is equal to -5, 5 squared, plus 50 times 5, and d of 5 is equal to 125 feet. Exactly as what I got in part C, but I used calculus, not geometry. Calculus is going to be better because not everything's going to be nice linear graphs. Okay, thank you for watching this video.